As you know, chromosomes are double-stranded DNA molecules that contain our genetic information with nitrogenous bases. Telomeres are structures that act as caps at the end of strands to protect them from damage during DNA replication. Our genetic information is at risk during replication because it can shorten our chromosomes. During replication, an enzyme breaks the hydrogen bonds that hold the bases together to allow the strands to separate. In order to begin synthesizing the new strand, a piece of RNA called a primer attaches to the original strand. However, when the primer attaches, it prevents us from being able to replicate the ends of the strand. Once the primer attaches, the rest of the strand can be synthesized because of cellular machinery. And as you can see, part of the DNA strand does not get replicated. When the cell divides again, the same process occurs. The primer will attach near the end of the original strand and the rest of the strand will form. For humans, we lose about 50 to 250 base pairs each time a cell divides. If this happened without telomeres, the cell would become inactive or even die off because there isn't enough genetic information to function. Telomeres are composed of nitrogenous bases as well. In humans, our telomere sequence is thymine, thymine, adenine, guanine, guanine, and guanine. This sequence occurs about 3,000 times and can be up to 15,000 base pairs long. Now picture the end of the DNA strand with its telomere attached to it. During replication, the primer will attach near the end of the strand, which is the telomere, and the rest of the strand will form. The original strand still becomes shorter each time the cell divides, but now it's the telomeres bases that are being taken away. Now you might be wondering, what happens when the telomeres shorten? That's where aging comes in. Studies have shown that shortened telomeres help indicate signs of aging. We see these effects in parts of our body where cells divide and replace others often. As people grow older, they often begin to grow gray hair, have wrinkly skin, or have a weaker immune system. However, it is still unclear whether telomeres cause these signs of aging or simply act as indicators, but the shortening of telomeres is affected as time passes by. Studies have shown that the telomeres in a newborn baby's DNA is often longer than the telomeres in an adult's DNA. In babies, the telomeres can range in length from about 10,000 to 15,000 base pairs. Some studies have shown that by the time that person's around 40 years old, they could lose up to 1,600 base pairs from those telomeres. Now you're probably thinking, that seems like a really small number. After 40 years of cell division, you're right, it is a really small number. And that's because we have an enzyme called telomerase. I've drawn my own version of the telomerase enzyme. Just know that those colorful things in the middle are the base pairs that it adds onto the end of the telomeres. The telomerase enzyme basically rebuilds our telomere ends by adding more of its base pairs onto it. This prevents our telomeres from shortening at a dangerous rate. Unfortunately, our cells divide so much that there isn't enough telomerase to keep up with the loss of base pairs. That's why our telomeres still end up getting shorter. Telomerase is active in sperm and egg cells, which get passed on to the next generation. If this wasn't the case, then people wouldn't be able to reproduce.